we will practice by solving the remaining recitation exercises in section 3.5. What do you know about section 3.5? What is the most important part that is still in your mind from the class of yesterday?
The conjugate.
The complex conjugate. What is it? They come in pairs. So if you have one complex zero, then its conjugate is also what? Is a zero. Is this always?
No, it's real.
If the coefficients of this polynomial are what? Are real. Great. What else? What? The complete factorization theorem. So important theorem. For any polynomial of degree n, it has n linear factors. You can write it as a product of n linear factors. And also the fundamental theorem of algebra. You are finishing now algebra, MATH001. It is about algebra. So you should know what is the fundamental theorem of algebra. Whatever the form of this theorem is, it's say in short that every polynomial has a zero. Every polynomial has zero. You can say it that way in short. In details, every polynomial of degree n, it has at least one zero. It might be, if it is only one, it means that it is of multiplicity n. It is repeated n times. So it has at most n different ones. It has exactly n. But of course, the repeated one are counted k times. The multiplicity, with multiplicity k, they counted k times. Okay, I think you are ready to continue. We solved this one in the previous class. Do you remember that? So let's solve now the second one. Please, in your notebook, solve this one. He gave you one of the zeros and he wants the sum of all the zeros. So the answer is B. How we obtain this answer? Let's go back and see first the mistakes that I have seen here. Okay, he said that 1 plus I is a 0. So this means that if you divide, you will get the remainder equals to what? If you substitute by 1 plus I, you will get 0. Okay? So in fact, what most of you did, I have seen that, they divide by 1 plus I, okay? By using the synthetic division, Abdulaziz, not the long one. Now, the synthetic division, it is about what? What you will do? You will check that the polynomial is written in a descending order from the highest power to the smaller power. And if there is any missing term, you should write 0 in the place of, okay? Now, it is a polynomial of degree what? Of degree 3. How many coefficients? At most, it has. It has, of course, the coefficient of x to the power 3, the coefficient of x squared, the coefficient of x, and the constant, only 4. I have seen that many of you, they write it like this: 1, -1, -I, -16, 16, 16i. What is this? These are not the coefficients. This is the coefficient of what? This is the coefficient of what? Be careful. So in fact, you have here 6 coefficients. They are not. So indeed, what you will do, you will write first of all the coefficient of x to the power 3, which is 1. Then the coefficient of x squared. What is the coefficient of x squared? -1 minus I. So in fact, you take here, it is x to the power 3 plus, take x as a common x squared as a common factor. You'll have -1 minus I. Then you will continue. This is -6x plus, this is the constant term, 16 plus 16i. So now the coefficient of x is -16. The constant coefficient is 16 plus 16i. Now do the synthetic division as you usually do. You will bring 1 down, then you will have 1 plus I, add, you will get 0, multiply, you will get 0, add, you will get -16, multiply, you will get -16 minus -16i. If you subtract, you will get 0, or if you add, you will get 0, as expected. Because it is 0, the remainder must be 0. Now, if we divide by 1 minus I, are we going to have 0?
No.
Why you are sure that it is no? First of all, it might be 0, it might be not, by the way. But it is for sure, you cannot say that it is 0. Because the coefficients here are not what? Are not real. So there is no guarantee that the offer is still valid, because it is valid only the zero conjugate theorem says when you have real coefficients. By the way, you don't need to divide by any other zeros, because this is a polynomial of degree what? 3. So we have now the factor, the last factor we have. The first factor is x minus the first 0. This is the first factor. The second factor is the quadratic factor we had here, x squared minus 0x minus 16, which is what? X minus 4 times x plus 4. And he's asking about the sum of all zeros. So in fact, what are the zeros? The zeros are 1 plus I, 4, and negative 4. What is the sum of the zeros? Is 1 plus I. 4 will be cancelled with negative 4. What is the lesson that you have learned from this exercise? Write the coefficients in the right way. Okay. Okay, let's go to the next question. Yes. Why not? It may have 3 or 2 or at most at least 1. Why not? It is a polynomial of degree 3. It should have, it must have 1. But it could have 2, it could have 3. Okay.
How do we get the first factor of p of x?
The first factor, which you mean x minus 1 plus I. 1 plus I is a 0.
Yes.
Then x minus this 0 is a factor. This is the factor theorem. If c is a 0, x minus c is a factor. And vice versa. If x minus c is a factor, c is a 0. This is the complete factorization theorem. Now, please solve this one. Find all the zeros of this polynomial. Again, I will pause the recording and give you time to solve it. Let's check the solution. This is the solution if you want to check your solution. I noticed that some of you tried to use the rational zeros theorem. You will get negative 2, but you will left up with the degree of polynomial of degree 4. You'll not be able to factor it. I didn't try, by the way, the synthetic division here, but no need to use the techniques of chapter 3 when you are able to use the techniques of chapter what? Of chapter 3. I also noticed that some of you, they forget to write the zeros. When they use the synthetic division, they wrote 1, 1, 8, 8. They forget to write the zeros. Be careful. Even if you are using it in the right way. Negative 2, some of you even they divided by negative 2, but they didn't get the 0. Okay. So I have noticed some of you, they only tried the negative zeros, and this is good, by the way. Because you by using the Descartes rule of science, there is no positive zeros, real zeros. There is no positive real zeros. So how to solve such question, Shabab? First of all, you need to think about it simply. You need to think about this by using factoring. So here you will take x to the power 3 as a common factor between the first 2 terms, plus 8 as a common factor between the last 2 terms. Now you have 2 groups. There is a common factor between them, which is x squared plus 1, and here x cubed plus 8. Now you factor this. You have 2 polynomials now. You can now factor each one of them completely by using the complete factorization theorem. Of course, this is x squared plus 1. You can write it as what? What are the zeros of this polynomial? I and negative I. So this is x plus minus I times x plus I. X to the power 3 plus 8, Abdul Qadir. What is it? It is sum of cubes. So it is x plus 2 times x squared minus 2x plus 4. Now we can find the zeros now. You cannot factor this more, ya shabab. Always the polynomial, the trinomial obtained from the sum of cubes or the difference of cubes, it is irreducible with real coefficients. So what we will do, we will now he is asking about all the zeros. So the zeros will be, the zeros are I, negative I, negative 2, and by using the quadratic formula, it will be b, negative b, plus or minus the square root of b squared minus 4 times 4, which will be what? 16. All over 2 times a, it is 2. Now, we will have what? Negative 2, positive or negative I. And here we have what? 4 minus 16, it is negative 12. So it will be 2 plus or minus I. Square root of 12, what is it? 2 square root of 3 over 2. So it is negative 2 plus or minus I. Take 2 as a common factor, you will have, cancel it with 2, you will have 1 plus minus I square root of 3. These are the zeros that we are looking for. It has 5 different zeros. Yes, Mansour?
Is it true to write it like this? I to square root of...
It's okay. It's okay, but just in a short way. In fact, you can list them, the 5 of them. Negative 2, I, negative I, 1 plus I squared, and so on.
No, I meant the quadratic formula. You write 2 plus or minus I to the square root of 3. Shouldn't I use the formal way to write it? 2I.
It's okay. We mentioned this, I think, when we studied for 1.5. If you have A, this is the standard form. Okay, if you have a plus 2i, 1 plus 2i, it's okay, 1 plus 2i. But of course, if you have 1 square root of 2i, it is better to write I before the square root to avoid I the square. It's okay, it's okay, but just to avoid the confusion here, yes, to put I inside the square root, this because this will be another story. We will study it in the future, inshallah.
Doctor,
Yes.
how did you know that we use the statistic division when we get a factor of degree 4?
It is a polynomial of degree 5. When we use the synthetic division, we will divide by x minus that number that you are looking for. So it will be of degree 5 divided by of degree 1. It will be of degree 4 for sure. Okay. Now let's go to the next question. Read it and try to solve it. In fact, we have here 2 questions, not one. 2 problems, not one problem. Let's solve it one by one. Let's start with this. Find the polynomial of least degree for which 1 plus I, negative 1 minus I are zeros, and the y-intercept is negative 2, where the polynomial has A, real coefficients, B, complex coefficients.
So should I, from the graph?
Do whatever you want. Try your best. You are here to learn. No problem. Don't be afraid from your mistakes. Let's see. Why? Why? You see? There is a problem. Is it long or you don't know how to start? You are right, but there is something missing. There is something missing at the beginning. There is something missing at the beginning. You are right. Just you need to focus on the calculations. Okay. Let me remind you, before solving this, let me remind you about how to solve such problems. What is the tool that we will use to solve this one? Which theorem? We will use here 2 theorems. Let me go back and show you the Let me go. Do you remember this example from the class of yesterday?
Yes.
What we did?
X minus I x plus I.
X minus the zeros. So we have 4 zeros, we have 4 factors. So at least we have a polynomial of degree 4. Okay. So it will be like this. What is A here? It is coming from the complete factorization theorem, the leading coefficient. We solved this example, and also we solved this exercise. Do you remember? Find a polynomial function of least degree having only real coefficients and 0 is 3 and plus 2i. What we did? It will be x minus 3, x minus 2 plus I, and x minus 2 minus I. The special offer, don't forget about it. I have noticed many of you, they write it just as a product of 2 factors. Why? So in fact, here, this is a product of 3 factors. Here, he didn't use A, he chose A to be 1 because he didn't mention anything about it. So in this is our tool, Shabab, the complete factorization theorem. If you have a polynomial, you can write it as a product of these linear factors. Let's go back to our polynomial. Let's start with the let's start with the complex coefficient. Easier. It is easier with the complex coefficients. Why?
No need to have a conjugate as 0.
To find the polynomial of least degree for which these are zeros. So in this case, our polynomial will be A. This A is the leading coefficient coming from the, if it is not mentioned anything about it, we can choose it to be, of course, 0. So this will be A multiplied by x minus the first 0, which is 1 plus I, times x minus 1 minus I. So we will start with the complex coefficients. If they are, sorry, this is minus 1 minus I. The second 0 is minus 1 minus I. Okay. Now the condition here, what he said that the y-intercept is what? The y-intercept is I0. Can we write here x minus minus 2 as some of you they did? Can we do that?
No,
This is y-intercept, not x-intercept. If he said x-intercept, you can do that. If it is x-intercept, it is a 0. It is a real 0. So how to represent this condition here?
P at x equals
P at
0.
P at
0.
P at 0 equals to negative 2. So now we can continue. How to continue now? I have some. I see some of you they stuck with the product. How to do that? You need to do it smartly. This is minus 1 plus I. This will be x plus 1 plus I. Do you notice that? Take a negative as a common factor, negative 1 as a common factor. Now what is this? This is difference of, this is x squared minus 1 plus I all squared. This is A times x squared minus, what is this? 1 plus 2i minus plus I squared. I squared is minus 1. This is A times x squared minus 2i. Right? Now use the condition that P at 0 equals to negative 2. This means what? This implies that A times 0 minus 2i equals to negative 2, which implies that A is what? Negative 2 over negative 2i, which is 1 over I, which is what? Negative I. So our polynomial is negative I multiplied by x squared minus 2i, which is what? Negative I x squared. Negative by negative is positive, and I by I is negative 1, so it is negative 2. Right? So what we did here, since the coefficients are complex, not necessarily real, we don't have the conjugate. We don't have the special offer, the free offer that if you get the complex 0, its conjugate is also a 0. Okay? So this is the function that we are looking for. Is it the same as we obtained? Yes. Now, what we will do, let me just write this here to avoid any confusion here. It will be 1 over I, which is negative I, just to order, because I will upload this file for you, maybe in the WhatsApp group. It will be -2 over -2i, 1 over I equals to -i. Okay, let's go back now to the case where we have real coefficient. What will be the difference here? Now the polynomial will be, what will be the least degree we may have? 4. Why? Because indeed here we have 4 zeros are given for us, not to only 2. So it will be a multiplied by x minus the first 0, which is 1 plus I, times the second 0, then multiplied by x minus the conjugate of the first one, multiplied by x minus the conjugate of the second one. And the condition still p at 0 equals to -2. Now here you need to be smart. Of course, you learned the trick from the previous work. So this is in fact 1 plus I, and this is x minus. It will be plus 1 plus I. And here similarly, you will have x minus 1 minus I. You wish that you have here x plus 1 plus I. Do you? 1 minus I mean. Do you have it? Yes, if you factor -1 out, this will be positive and you will have 1 minus I, and you still have the same condition here. Similarly, you will have now the first two factors are difference of squares. So it will be x squared minus 1 plus I, 1 plus I all squared, multiplied by x squared minus 1 minus I all squared. This is equals to a times x squared minus, you can now, you know it from before. So it is 1 plus 2i minus 1 times x squared minus 1 minus 2i minus 1. This will be equals to a times x squared minus 2i times x squared minus, it will be plus 2i. And this is equals to what? A times x to the power 4 minus 4i squared, because it is also difference of two squares. What is I squared? -1. So this will be plus 4. Okay, so here we are done. Just we need to find what is a. P at 0, it is -2. This implies that a times 0 plus 4 equals to -2, which leads to a equals to -2 over 4, which is -1/2. So our polynomial is -1/2 multiplied by x to the power 4 plus 4, which can be written as -1/2 x to the power 4 minus 2 with real coefficients. It is a polynomial of degree 4 with real coefficients. Yes.
So why we in the first step, why we multiply by the conjugate?
The special offer that we told you about, the complex conjugate theorem. Let's go back to remind you about it, as Rashid. Read the last one. If the polynomial p has real coefficients, and if the complex number z is a 0, then its complex conjugate z bar is also a 0. You got it?
Yes.
But if the coefficients are complex, we don't have this theorem. We may have the conjugate might be zeros, might be not. But here you will guarantee if the real coefficients, if the coefficients are real, for sure that the conjugate will be a 0 also.
Yes, I know it's 0 if the coefficient was a real number. But I mean, why we multiply it?
The complete factorization theorem, Rashid. These are the zeros. C1, C2, Cn are the zeros. So if you have 0, x minus C1, the first 0, multiplied by x minus the second 0, and so on. If it is a 0, x minus it is a factor. Okay? It is the same here. Why here we write x minus I, x plus I? The same idea. Because it is a 0, x minus it is a factor. Got it?
Yes.
This is the factor theorem. So let's continue. We still have time. You know, Shabab, you don't have so many old exam questions in this section and in chapter 3, I think, as well. So it is good to practice by solving the exercises of the textbook, at least the ones in the slides. You can check the answer. The answer is in your textbook. You can find the final answer there. Now, let's have a look at some old exam questions. For the first one, what you will do to solve it. I think I have seen this before in section 3.3. So here, the remainder. So what you will do, you will just find P at what? At negative I. It should be equals to what? To the one that you will looking for. So A plus BI will be equals to the value of the function at negative I. You will just substitute. You can continue doing this, right? So what it will be negative. Did we solve it before?
Yes.
I think we solved it. Yes. So you can continue. I will leave it for you. Let's go to the next one. If negative 1 is a 0 of multiplicity 2 of this polynomial for some constant k, then the remaining zeros are. Solve it. Or tell us, because we need to solve as many as we can. So what is the plan? Mansour? Synthetic division.
Or it's much better to use the long division. Yeah, because he said that it's multiplicity divided 2 times.
Don't follow the advice of Mansour. Try it at home, not here. Okay, you can, yes, but it is not the best way. Yeah, Shabab, when you can use the short division, why you would use the long division? Not in this exact exercise. I don't think so. Because here, by the way, he is asking about what? He is not asking about k. If he's asking about k, your advice will be very bad indeed. You will not be able to find k from that.
That's why I think so.
Okay. But also, if you apply this long division with k there, k will stay there, and you will calculate k without need to do that. Try it both methods, and you will realize what. So what you can do is
k will be 5 because it's a 0. So the remainder will be 0. So it's k minus.
do you need to find k? We will see. So the original idea is to use the synthetic division. You will divide by -2 twice, and you will factor the resulting one, and you will find the remaining zeros. So you have, in fact, it is a polynomial of degree 4. He gave you already 2, 1, but double. You need to find the other zeros. So what you will do, did you obtain them? So you will divide by -1. So you will have 1, 6, 14, 14, and k. You will divide by -1. So you will bring 1 down. Then what we will have? -1, 5, -5, 9, -9, 5, -5, k minus 5. If you want to find k, what you will do here? This will be equals to, and this implies that k is 5. This is if you want to find k. We are not looking for k, and we don't have it anymore. This is what is good. It will disappear. Now we will divide by -1 again, because this will be polynomial of degree 3. We are not able to factor it, so we will divide by -1 again. So it will be -1, 4, -4, 5, -5, 0 as expected. If you didn't get 0, you had a mistake. Now the remaining polynomial is what? X squared plus 4x plus 5. Can we factor it? In fact, you need to solve it by the quadratic formula, and you will put this equals to 0. This will be -4 plus or minus the square root of 16 minus 4 times 5, 20 over 2 times 1, 2. This is what? -4 plus or minus 2i over 2. This is -2 plus or minus I. Which answer is the right answer? It is D. Got it, ya shabab? Any question about this? Let's try another one. If 3i is a zero of this polynomial, then the product of all real zeros is. So he is asking about the real zeros, the product of the real zeros. What you will do to solve it? You will divide by what? And negative 3i. Check that the coefficients all are real. So you will apply the synthetic division. You will divide by 3i. You will have 2, -1, 12, -9, -54. Make sure that there is no missing. If there is a missing term, write 0. Now we will bring 2 down. We will have here what? 6i, -1 plus 6i. And you can here apply what you are talking about, Masood, now. This is the long division. You can do it here. You will divide by what using the long division? Long division by 9? By x squared plus 9. X squared plus 9. Okay, now we will continue. Start multiplying 6i by 3i. It will be what? -18 minus 3i. Add, you will get -6 minus 3i. Multiply -3i by 3i. It will be what? It will be 9 minus 6 minus 18i, right? Then you will get what? -18i. It will be what? 54. Of course, the remainder should be 0. If it is not, you have a mistake. Divide now by -3i. You can start with -3i and then by 3i if you want. So this will be what? -6i, -1, 3i, -6, 18i, 0 again. And now we left up with what? With 2x squared minus x minus 6 equals to 0. Try to factor it. If you cannot factor it, you need to use the quadratic formula. Good idea. Because no, be careful. Because it might have no real. Maybe the solutions are complex. But forget about the choices. Without choices, you cannot do that, ya Muhammad. Be careful. Because maybe the solutions of this also are not real. But since he is asking about the product of real, there are real zeros for this. And if you look at the social, even is zeros, because some of you they said if the product is 0, then they are not real. No. So in fact here, since he's asking about the real of the product of the real zeros, they are real. So it is here you have 2 options. You can we? No. Let's try 2x and x. Let's see why not. And this will be 3. Why not? No, because 2 here, there is a 2 here. 2 cannot here. Here 2 should be here. Like this? No, this is minus. This is plus. Now, can we have it like this now? We can factor it. In fact, we have 2 zeros here, -3/2 and x equals 2. And the product of them is what? -3. In fact, we can have the product by another way. Just we make sure that they are real. Will be negative, will be c/a, -6/2, which is -3. So here the product is also from here, the product is -3 times 2 multiplied by 2, which is -3. From here, from the original equation, the product can be also calculated this way. Yes, from section 1.4. So from here we have this. Excellent. Do we have time for other exercises? This is an easy one. I think it has a solution. So what you have here? Polynomial of degree 3 with real coefficients having zeros. He gave you the 3 zeros.
X plus 3 and
X, we will just write it as x plus 3, x minus, and you will use a to find the another factor. A polynomial function of least degree with only real coefficients has zeros -1 of multiplicity 3 and 2i of multiplicity 1. If f at 0 is 4, then the leading coefficient of f is, he's asking for what?
A.
For a. How to solve it?
We have right.
It will be a times x minus x plus 1 to the power multiplied by.
X minus 2i times x plus 5.
Excellent. And you can, of course, now no need to expand, no need to do anything. Just substitute to find what is a. In this question, no need to expand. Just you need to find what is a. I think this is enough, Shabab. We will stop here and let the remaining exercises for you to practice. Please don't read solutions. Try to solve without knowing what is the answer and without looking at the solution. You can just use it as a check at the end.